Welcome to this video where I will be going over the 2022 Paper 1 non-calculator paper for the higher tier. Now usually I don't like to go over an exam paper so soon after the exam because some students may feel upset when they realize that they haven't done something correct. However, I do understand that some of you may want to go through the answers to this because you want to see how well you did. And it also helps you prepare for the next two papers. For example, if you feel that you didn't gain enough marks on here, then you will prepare better for papers 2 and 3. So let's begin. Now, I've done my solutions already here. So what I'll do largely is just talk through those solutions. And where I feel that I need to go and expand into thorough explanations, I will do so. So we are going to begin with question 1. So the first question here, very straightforward, inequalities, just like dealing with equations. So you want to take the minus 27 to the other side. So you add to the other side. So 8 plus 27 giving you the 35. 7x remains here. And then you divide by 7. So you have x is less than 5. So that's the answer to the first one for 2 marks. Question 2, it says write 124 as a product of its prime factors. So the first thing you do is you are looking to divide by prime numbers. Easiest prime number, remember this is a non-calculator paper, it's 2. So I'm going to divide by 2. So 2 times 62 gives you 124. So 2 is a prime number, so you circle that. And 62, you continue breaking that up. So I divide by 2 again, and 2 is a prime number, so I've circled it again. And 2 times 31 is 62, and 31 is also a prime number. So then I write 2 times 31 as I've done here. And then I can rewrite it as 2 squared times by 31. So this is a product of its prime factors for the number 124. Question 3. A delivery company has a total of 160 cars and vans, and the ratio to the number of cars and the number of vans is 3:7. Each car and each van uses electricity or diesel or petrol. 1/8 of the cars use electricity. 25% of the cars use diesel. The rest of the cars use petrol. Work out the number of cars that use petrol, showing when you're working. So the first thing that I want to do here is I want to add the ratios right there. So 3 plus 7 is equal to 10 parts. Now there are a total of 160 cars and vans. So I'm going to do 160 divided by 10. That means 16 per part. Now for the cars, there's 3. And for the vans, there's 7. So cars will be 3 times by 16 and the vans will be 7 times by 16. And then 3 times by 16, I get 48. And 7 times by 16 is 112. Now, if you notice here, I did an alternative method for finding 112 because 7 times 16 is a large number, and without a calculator, some of you may feel that you're wasting time working this out. So another way I found 112 is because I've already got the value for the cars, which is 48, and I knew that a total of 160 cars and vans, I just did 160 minus 48 to find the number of vans. Right, moving on. Now, it says 1/8 of the cars use electricity. So 1/8 of 48 because there are 48 cars. To calculate this, I did 48 divided by 8, which gives me 6 electricity cars. So this is the cars that use electricity. Now, 25% of the cars use diesel. So I'm going to work out 25% of the cars amount, which is again 48. So 25% of 48 is simply 48 divided by 4. That gives me 12 diesel cars. So now, what do I have? I have 6 electric cars and 12 diesel cars. If I add them together, I get 18. So I have a total of 18 cars which are electric or diesel cars. Now the rest of the cars use petrol. So all I need to do is 48, take away the 18, and that leaves me with 30. So I've got 30 cars which use petrol. Question 4. Write 1.63 times 10 to the power of minus 3 as an ordinary number. So how do we do this? Now, it says minus 3. That means this number overall will be smaller. So it will go towards the right-hand side. So the 1 was here, right? So the 1 will take 1, 2, 3 steps to arrive here. 3 steps because of this power here. And the rest of the numbers will just shift along. So I get 0.00163. And that's the answer as an ordinary number. Next, write 438,000 in standard form. So this time I'm going from ordinary to standard form. Once again, I've written 4.38 times 10 to the power of 5, and I'll just quickly explain that to you. So look at the position of the 4 and the decimal place. Now the decimal place in this question is right there. So I've got the 4 to come 1, 2, 3, 4, 5 steps. And of course the 3 and the 8, they shift along. So the 4 is right there now. So it's going to be 4.38. So 4.38. Now, how many steps did I take? I took 1, 2, 3, 4, 5. I've taken 5 steps, so my power is 5. Now this is a large number, which I'm making smaller, so I'll have a positive power. Part C, work out 4 times 10 to the power of 3 times 6 times 10 to the power of minus 5. Give your answer in standard form. Now with these questions, the first thing you want to do is 4 times the 6, which is 24. And you add the powers. Add because with indices, 10 to the power of 3 times 10 to the power of minus 5, you add the powers because you're multiplying with the same base. So 3 plus minus 5. So when you write 3 plus minus 5, you've got two signs which are next to each other. So the minus is the overall winner. So you'll have 3 minus 5 giving you minus 2. So you have 24 times 10 to the power of minus 2. Now a mistake that you can make is leaving your answer like this. This is not in standard form. Why? Because this number has to be between 1 and 10. So we need to make this 2 point something. So we'll do 2.4. Now again, I move the 2 right there. I've moved it up by 1 step, which means I increase this power by 1. So minus 2 plus 1 gives me minus 1. So once again, I'll just write that here. So minus 2 plus 1, so that gives me minus 1. So the minus 1 is my power, so I'll get 2.4 times 10 to the power of minus 1. And that is 4 marks. Question 5. Here is a regular hexagon and a regular pentagon. Regular means that all the sides and all the angles are exactly the same. They are equal. So the question wants me to find the angle marked X, which is right here on the outside. The first thing I did is I worked out the interior angle of the hexagon and the interior angle of the pentagon. Now, what do we know about the angles on a point? They all add up to 360. So how did I work out this 120? Well, we know there is a formula for polygons, which is n minus 2 times by 180. And this formula is the sum of the interior angles. So it tells us what all of the angles of a polygon add up to. So n is the number of sides. So a hexagon has 6 sides. So 6 minus 2, and that gives us 4. So 4 times 180, which is 720. And then I did 720 divided by 6. Now, a lot of you may struggle with calculations like this without a calculator. So a quick technique that I use here is I covered up the 0 at the top, and I did 72 divided by 6, which I know is 12. And then I added the 0 back, so giving me 120. In the same manner, I did this one. So this has 5 sides. So 5 minus 2 times by 180. 5 minus 2 is 3. 3 times 180 is 540. So once again, 540 divided by 5 because it's got 5 angles. So 540 divided by 5 is what I needed to work out. Now, unlike this one, I can't just cover up the 0 and do 54 divided by 5 because it doesn't give me a nice number. What you could do is 540 divided by 5 and use your long division. So how many times does 5 go into 5? It goes in once. How many times does 5 go into 4 then? It doesn't. So I have to use 40. 5 into 40, I know it goes 8 times. Now, because it doesn't go into 4, I'm going to put a 0 here first, and then 5 into 40, 8 times. So 108 is my final answer. So now that I know that this is 120 for this angle and 108 for that angle, all I need to do is 360, take away the 120, take away the 108, and that gives me 132. So X here is 132. Now, on to the next question, question 6. Complete the table of values. What it wants you to do is substitute the values of X into this equation and find Y. So for the first X value, I put minus 1 in here and in here. So minus 1 squared is 1, and 3 times by minus 1 is going to be a positive 3. So 1 plus 3 is 4, plus the 1 is 5. And I did the same thing with the 2 and the 4. And the 3 as well. So I substituted those values in there and I got those values. Next, it says on the grid, draw the graph. So all I need to do is plot these coordinates. So the first one here is going to be minus 1, 5. Second one is going to be 0, 1, 1 minus 1, 2 minus 1, 3, 1, and 4, and 5. So all I did is for the minus 1, 5, I'll go to minus 1 here, go up to 5, I plot that here, next 0, 1, 0, 1, so on and so forth, and I did this. And then I just draw a curve through those points. The question then says, use in your graph, find the estimates for the solutions of the equation. Now what that means is where it cuts the x-axis. So this is the x-axis right here. Where does the curve cut the x-axis? And if you go in here, you can see that it cuts approximately at 2.5. In fact, it's not approximate. It's pretty much dead on 2.5. That's one of the roots. So 2.5 or solutions. I use the word roots. You actually use solutions. Same thing. And the other one is around 0.5. Now, in the exam, you may have a different curve, slightly different. You may not have drawn it the way I did. It might be a little bit off, but the examiner will allow for some margin right there. So now you might not have put exactly 0.5 and 2.5. You may have something just near to those numbers, and that's perfectly all right. Question 7, you have two cubes, A and B. You're told that cube A has a mass of 81 grams and cube B has a mass of 128 grams. It wants you to work out the ratio of the density of cube A to the density of cube B. Give your answer in the form A and B, where A and B are integers. So because I know I am dealing with mass and volume and density, I have my formula up there, mdv. So that's the first thing that I did. I wrote this formula down and I will use it when I need to. So I will now calculate the volume of both of these cubes. So obviously the cube means that all the lengths are the same. So for this one, it means 3 times 3 times 3, and the volume is 27 centimeter cubed. For this one, it's 4 times 4 times 4. That gives me 64 centimeter cubed. Now, I will calculate the density of both of them. Now, density, going back to this formula, if I just cover up the D, I get mass divided by volume. And that's how I find my formula. So for cube A, the mass was 81 and the volume was 27. So it's going to be mass divided by volume, 81 divided by 27. And that gives me 3. For cube B, I did 128, which is the mass, divided by the volume, which is 64. So 128 divided by 64, and that gives me 2. So 2 grams per centimeter cubed and 3 grams per centimeter cubed. So because the question says put it into the form AB, so this is my A and this is my B. So ratio of A to B. So 3 to 2, and that's in its simplest form, and it's integers as well. Question number 8. The table shows the amount of snow in centimeters that fell each day for 30 days. Work out an estimate for the mean amount of snow per day. All right, so we have that table right there. So we need to find the midpoint of each of these class intervals. So the midpoint of 0 to 10 is 5, 10 to 20 is 15, so on and so forth. And then we have the fx column, which means frequency times by the x. So 8 times 5 is 40, 10 times 15 is 150, 7 times 25 is 175, 2 times 35 is 70, 3 times 45 is 135. And then using the column method, that's what I did. I just added these along right there. I got 570. Now it's already told me that this is 30 days, so the total of the frequency is 30. To find the mean, I do the total of the fx divided by the frequency total. So 570 divided by 30, and that gives me 19. Again, I use long division to do this. So this is a non-calculator paper, and you have to do stuff like this if you can't work those out. Question 9. A cube is placed on top of a cuboid. So this is a cube, this is the cuboid. To form a solid, the cube has edges of length 4 centimeters and the cuboid has dimensions 7 by 6 by 5. Work out the total surface area of the solid. Now, you may be tempted to calculate the surface area of this cube and the surface area of the cuboid and add them together. But the surface area is missing this part on the inside right there underneath that cube. All right, so what you have is, let's start with the cuboid. You have this face and the one at the back. You have this side and the one on this side. You have the bottom, all of it, but you don't have the full top surface because the cube is sitting on there, and that's not to be included, the part that the cube is sitting on. In the same manner, for the cube, you have the top, but you don't have the bottom because the bottom is covered and you don't include that in your total surface area. Just the two sides, the front and the back, and one top right there. So what I've done here is I've worked out the surface area of one face of the cube. Now the cube, 4 times 4, so that's 16. So one face is 16 centimeter squared. So how many sides are there on display? So 1, 2, 3, 4, 5. 5 full sides are on display. Therefore 5 times by 16 gives me 80 centimeter squared. As for the cuboid, we have 1, 2, 3, 4, 5 full sides. And we have part of that side, which we'll come to later on. So let's work out the bottom, so as I've done here. So 7 times 6, so 7 times by 6 is the bottom right there. We have one of those. For the next one, we have 6 times by 5, which is this side right there. And we've got another 6 by 5 on the other side right there. So I've done 2 of those. Then we have 7 times by 5. 7 times by 5 is the front right there, and we have it at the back as well. Again, 2 of those, so I've multiplied that by 2. The only one that I haven't multiplied by 2 is the 7 times 6. So this is just the one at the bottom. Remember, I don't have the one at the top in full. So that's what I've written here, part of 7 times 6 at the top. Right, so let's work these out and then we'll work on that one. So 7 times 6, 42. 6 times by 5 times by 2, 60. 7 times 5 times by 2 is 70. So in total, all of this gives me 172 plus this part that I need to work out. So this is how I worked out this part. So 7 times 6 is all of that on the top of the cuboid right there. I'm going to take away the 4 times 4, which is this bit right there. So I'm going to take that bit away from there, which is why I've done the takeaway sign right there. Okay, so 7 times 6 is 42. 4 times 4 is 16. 42 minus 16 gives me 26. So this part right there, so let me just get rid of this. So this 26 is referring to this area right there on the top of my cuboid. So going back to this now, remember 172 was these, part of 7 times 6, the top is 26. So I add the 26 to the 172 to give me the total area for the cuboid, and then I add the 80, which was the surface area for the cube. Give me a grand total of 278 centimeter squared. Question number 10, we have to complete the cumulative frequency table and then draw our cumulative frequency graph. So in order to complete this table right there, cumulative frequency means to add the frequencies. So first one's going to be just 10, so we wrote 10 right there. Then we add the 15, which gives us 25. Then we add the 25, which gives us 50. Then we go back and add the 30, gives us 80. 80 plus the 5, 85. And 85 plus 15 is 100. Next, we go and plot these values. Now, where do we plot this? We'll do 50 on the x-axis and 10 on the y-axis. 100 on the x-axis, 25 on the y-axis. So I've done that right here. So 50 to 10, 100 to 25, so on and so forth. Now, before I did this, I had to work out what each of these squares represents. So in order to do that, just do a quick count. So you know that from 0 to 20 here, and you've got a total of 10 squares. So each of them is worth 2. So 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, and so on and so forth. It goes all the way across. So I've done that. I've plotted all the values, and you can actually use a ruler, or you can do it freehand. I've used a ruler here. I've drawn my cumulative frequency graph. Next, it says use your graph to find an estimate for the number of days on which the profit was less than 125. What I did here is I found where 125 is. It's between 100 and 150 right there. Went up, hit the graph, went across, and read. Less than 125 is this way, so I'm looking for everything under that. So a total of 40. So 40 days, the profit was less than £125. Next, it says use your graph to find an estimate for the interquartile range. The interquartile range is the upper quartile, take away the lower quartile. The upper quartile is your 75% and your lower quartile is your 25%, or 3/4 and 1/4. Now, if I want to find my upper quartile, my lower quartile, my 75% and my 25%, Let's start with the lower quartile, the 25%. So I do 100 divided by 4. 100 divided by 4 is 25. I found where 25 is here. So I went across, went down, and it gave me 100. So my lower quartile is 100 right there. Now for the upper quartile, which is 75%, once again, very simple. Because I have 100, 75% is going to be on 75. So I found 75 right there, went across, hit my graph, went down, read it, and it's around 190. Now, because it's an estimate, your answers, they may differ to mine slightly, okay? But it's no problem if they do. So finally, my answer, upper quartile, take away the lower quartile, gives me 90. So I have a final answer for 90. Question 11. You have a ratio for the number of lime-flavored sweets, strawberry-flavored sweets, and orange-flavored sweets. And the ratio is 9 to 4 to x. Cormac is going to take at random a sweet from the bag. The probability that he takes lime-flavored is 3/7. Work out the value of x. First thing I did is I added up the ratios. So 9 plus 4 plus x, giving me 13 plus x. Now, I use this information for the lime-flavored sweets. So I know that the probability of lime, okay, just ignore that for a second, is given to me in the question as 3/7. But I found my own version of that probability. How? Because lime is the 9 right there, I did 9 out of the total of this, which is 13 plus x. So I wrote 9 over 13 plus x is equal to 3/7, which is what they gave me. And this part here, okay, because it's just equal to the probability of lime, that's all it means. So I'm just going to look at that, is an algebraic fraction, which I need to solve. So how do I do that? I multiply the 7 up here and the 13 plus x up there. So that gives me 9 times 7 and 3 bracket 13 plus x. 9 times 7 is 63, and then 3 multiplied by 13 is 39. 3 times by the x is 3x. And then I take the 39 to the other side. So 63 minus 39 is 24, and 3x is still left there. And then I divide by 3. So 24 divided by 3 gives me 8. So my value for x is 8. Question 12. Express this recurring decimal as a fraction, showing all your working. Now the recurring part of this is the 17. So I can write x is equal to 0.1 and then 17. Now what I want to do is I want to multiply this by a number so that the 171717 part of it is just after the decimal place. So I want to get rid of this one, which is on its own, solo, and then I just want 171717. Now I can do this easily by multiplying by 10. So that is one of my numbers, but I need another number to take away from that because I can't use this x version. So first of all, I will multiply by 1,000. Now multiplying by 1,000 means, you know, the first 17 that comes here will go onto the other side, and it's just going to be 1717 after that. So it will give me 117.171717. The 7 takes 3 steps when it's multiplied by 1,000. So 1, 2, 3 will end up right there as it has here. And these 1 and 1 will just move along with it. So 10x will move the 1 from the x onto this side. And then the 1717 will just step up as it has here. So 1.171717. I will take them away. So 1000x, take away 10x is 990x. For this part, what we can look at here is look at the decimal place. Can you see after the decimal place, the numbers are exactly the same. So we can do that, take away that, which is 0, gone, leaving us with just the integer values. So 117, take away 1, which is 160. And therefore now I have 990x is equal to 116. I'll take the 990 to the other side by dividing. X is equal to 116 divided by 990. It can be further simplified, but you don't have to 58 over 495, which is to divide by 2. But the question doesn't say that, so it's okay if you don't. But if you did, well done to you. Okay, so on to question 13. This question, I believe, was the first of the 2 difficult questions on this paper, well, which I thought that were quite difficult. Obviously, we will know about the famous last one. Okay, let's begin. It says a right-angled triangle is formed by the diameters of 3 semicircular regions, A, B, and C, as shown. Show that the area of region A, so the area of that, is equal to the area of region B plus the area of region C. All right, now obviously my working out is all over the place, but I will explain it step by step. The first thing you want to do is start off by using the Pythagoras' theorem, which we know is a squared plus b squared is equal to c squared. C usually meaning the longest side, but here we are going to refer to c as 2a. And I'll explain why I've done 2a and not just a, b, and c. It's just a little something that I did to make things easier. All right, so what do we have? We have 2c squared, so that's our if you like, our a squared plus b squared equals c squared. All right, so we are calling a squared here, right there, the usual a squared for Pythagoras' theorem, by the way, okay, is 2c squared plus 2b squared. So that's 2c squared plus 2b squared, and that gives us the square of that side here, the hypotenuse, which is 2a squared. And if we expand the bracket, we get 4c squared, and we get, for this bracket, we get 4b squared, and that's equal to 2a bracket squared, which is 4a squared. Now, if we simplify this, so if we divide throughout by 4, we can have c squared plus b squared is equal to a squared. So if I divide by 4, all these 4's disappear. Now, let me explain this part. So if we go back to the question, it says the area of region A. The region A is our semicircle, is equal to area of region B and C. How do we find the area of a semicircle? Well, we know that the area of a full circle is just pi r squared, r being the radius. But because it's a semicircle, we're going to divide by 2. Okay? We can also write this as half pi r squared. Dividing by 2 is the same as multiplying by a half. Now, if we look at area A, we're going to have half times by pi times by radius. Now, the radius, the diameter is 2a. So the radius is going to be half of 2a. So half of 2a is just a. And that's why I had it as 2a, 2b, and 2c for the radiuses. So it's going to be, area A is going to be equal to half times pi times a squared, which simplifies to half pi a squared. In the same manner, area of B is going to be half times by pi times by the radius squared. And the radius of B here is divided by 2, the diameter, so you just get b. So it's b squared, which simplifies to half pi b squared. Finally, the area of C, which is half times by pi times by c squared, so that simplifies to half pi c squared. So on to the final part right here, we are going to add the area of B and C, because area of region B plus C is equal to the area of region A. So B and C, the areas, area B, area C, right there. We're going to add these two together. We're going to add them, and that should equal that. And we'll show you how. So let's add these together. So area of B and C, half pi b squared plus half pi c squared. And if we factorize out the half and the pi and put the b squared plus c squared into a bracket, so this multiplies to give you exactly that, we are left with half pi bracket b squared plus c squared. Now, if we go back to this, our Pythagoras, we know that b squared plus c squared is equal to a squared, right? If we, obviously the outside is the same, but the inside here is basically a squared is equal to b squared plus c squared. So I've replaced those two with just the a squared, giving me half pi, which is from here, a squared. And half pi a squared is the area of region A. So the area of A. And there I have proved it. Hopefully that makes sense to you. On to question 14. We have a speed time graph and we've got a curve right there, and we're told to find or estimate the gradient of the graph at t equals 2. Now the gradient is found by drawing a tangent to the point where you want to find your gradient. In this case it's 2. So I'll go along the x-axis, I find where 2 is, see where it hits, and it hits right there, and I draw a tangent. So using a ruler, you draw a line right there. Tangent means it touches that point once, okay? Now, your line might be slightly different to mine, and that's okay. What I want to do on this line is I want to find 2 points. So I found the point here as 0 and 0.8 for my x and my y, and 4 and 5. So 4 and 5 right there. Yours could be different, okay? Now, to find the gradient, we do y2 minus y1, and the x coordinate, one x coordinate, take away the other x coordinate. So my y2 is my 5, and my y1 is my 0.8. So I did 5 minus 0.8. And likewise, x2 is 4, and x1 is 0, so 4 minus 0. So I did 5, take away 0.8, which is 4.2, and 4 minus 0 is 4. Now the answer to this is actually 1.05, which I worked out in my head by doing 4 divided by 4 and 0.2 divided by 4, which is 1.05. But the question did say that I can estimate. So what I did is I rounded the 4.2 to 4. And I got 4 divided by 4. I don't need to round this because it's a nice number. And that gives me 1, which is roughly the same as that anyway. And the question did say estimate. So an estimation for the gradient is 1. Next, it says, what does the area under the graph represent? Speed, distance, and time. That's where it comes from. So we've got speed and a distance. So therefore, it represents distance. All right, question 15. Prove that A, B, and C lie on a straight line. All right, so what I did here is I worked out what B to C is. Now, B to C is going to be AC take away A to B. So AC is 15A plus 20B, which I've written here. And AB is 3A plus 4B, which I've written here. So 15A plus 20B minus 3A plus 4B. And I just take away the like terms, or added or collected the like terms, which gives me a total of 12A plus 16B. So this is BC, 12A plus 16B. Now I factorize the 4 out, because can you see the 4 is a common factor of this. So I took the 4 out, and inside the bracket I had 3A plus 4B. Now the question says that prove that they lie on the same straight line. So they'll have the same direction, but possibly different magnitude, the length, okay? So I wrote down AC once more right there, but this time the AC, the 15A plus 20B, I factorized the 5 out. So 15 and 20 have a 5 as a highest common factor. So I took the 5 out. And can you see on the inside, I've got the same thing, 3A plus 4B, the same as B to C. And AB is already in the form 3A plus 4B in the question. So can you see all of them have the same vector direction, but different magnitudes. So because they are a multiple of A to B, they lie on the same straight line. Next, it says D, E, and F are 3 points on a straight line such that D to E is given to you, E to F is given to you. Find the ratio for the length of D to F and the length of D to E. So I drew this on a line like this. Obviously this is negative, so it means it's going the opposite way, but this is just for my working out references only. So I found D to F, okay, because the question needs me to find D to F. So D to F is going to be D to E plus E to F. So I add that and that together, as I've done here. If you work this out, you get minus 7.5E minus 15F. Collect the like terms. So here I've written down the ratio DF to DE. So DF is that right there. DE is given to me in the question up there. So I'll put DE right there. Now, I can divide both of these by 3. If I divide this by 3, I get E. Divide this by 3, I get 2F. Divide the other side by 3, I get minus 2.5E minus 5F. Next, I don't do any division. All I did is simplify it by factorizing this. Okay, factorizing the 2.5 out on this side. So I'm not dividing this side by 2.5. I'm just factorizing here. So it looks as though I'm dividing as well on this side. But I'm not dividing, I left that 2.5 right there. See, when I did that one, I didn't leave the 3 on the outside. So I took the 2.5 out. And when I take the minus, and it's a minus 2.5 I took out, I have inside E plus 2F, which is exactly the same as that. I don't touch this. I left that as it is because I'm not doing anything on this side. And I'm not changing anything here, but I'm just changing the form of this by factorizing out, okay? Just to be clear. So I've got minus 2.5 lots of E plus 2F. And that's my ratio, right? This E plus 2F, we can call it X. Okay, so E plus 2F, let's call it X. And then E plus 2F on this side is also F. So we have this as, let's ignore the X's for now. So we can divide by X. What do we get? We get minus 2.5 is equal to, sorry, not equal, ratio to 1. Minus 2.5 is simply 5 over 2 to 1. And now if we make this into a whole number, because the question says, or it should say actually whole numbers, but no problem. We can multiply both sides by 2, so we get minus 5 on this side and 2 right there. Now we can ignore the minus because that just means a direction, but the ratio of D to F to D to E is 5 to 2, as I've got right there. All right, so question 16 here. First aid test has 2 parts, a theory test and a practical test. The probability of passing the theory is 0.75, and the probability of passing only one of the two parts is 0.36. Two events are independent, which means one doesn't have an effect on the other. Work out the probability of passing the practical. So I've drawn a probability tree diagram. So the first part of my probability tree diagram is theory tests, and the second part is practical. So I know that the probability of passing is 0.75, so pass, and therefore the failing would be 1 minus that, so it's 0.25. The second part needs its branches, and remember they're independent, so whatever happens here doesn't have an impact on that one and vice versa. Now I don't have anything for the probability of passing or failing, so I'm going to call passing x and failing 1 minus x, and I've done the same thing there. And the question says that the probability of passing only one of the two parts is 0.36. So if you look at what I've done here, probability of passing only one part is 0.36. And then here I found the combination of passing only one. So that could be a pass here, but it will have to be a fail there. So 0.75 and 1 minus x. So 0.75 and means multiply, so I have to multiply the second probability, so 1 minus x. Or I could have a fail on the theory, but a pass on the practical, so 0.25 and x. So 0.25 times by x right there. And those two, when you add them together, because it's either pass and fail or fail and pass, and or in probability means and. All right, so I've set up a nice equation there, and I just need to solve that. So expand this out, I get that, expand, well, that's just 0.25x. Collect the like terms, take over the x's onto one side, numbers onto the other side, so on and so forth, and you get final answer for x is 0.78. So the probability of passing the practical is 0.78. All right, question 17. Y is directly proportional to the square root of t. Y equals 15 when t equals 9. And then you've got that for t as well, which we'll come to in a second. Let's start with the first one. So y is proportional to the square root of t. That means equals k. I've got a video on lots of these topics, so do go and check it out on my channel. Just go into the playlist or do a search in my channel on the YouTube search bar. So what I do is I use the values that it's given me to find a k value, the constant. So y is 15, t equals 9. So 15 for y and t is 9. The square root of 9 is 3, so it's k times 3, which I can write as 3k. Divide the other side by the 3, so 15 divided by 3, k equals 5. So I'll go back in here and I'll replace the k with 5 as I've done here. So my equation for this is y is equal to 5 root t. Now the next one I'm going to concentrate on. It says t is inversely proportional to the cube of x. T equals 8 when x equals 2. Similarly, I've done the same thing, but inverse means 1 over. All right, so t is inversely proportional to the cube of x. Once again, that means equals and k. So I write it like that. So I've got 8 from here. So I substitute 8 for t. 2 for x, so 2 cubed. So 2 cubed is 8. So therefore, k over 8. And then I take the 8 to the other side, multiplying, giving me 64. So, and now I've got my final formula. So I substitute the k value right there. So k is 64. So t is equal to 64 over x cubed. And that's my second equation. Now the question says, find a formula for y in terms of x, giving your answer in simplest form. Now, if you look at our two equations that we found, okay, we've got t right there, which we can substitute in there. So we can say, we can equate them. So y is equal to 5 root t. Remember, this was t, but t is now going to be replaced by all of that. So 64 over x cubed. Now, if I work this out, I can just do the square root for both of them individually, like I've done here, and this is multiplying, so I've just done a multiplying sign here. The square root of 64 is 8. And this one here, I could write it as, remember, root of x is the same as writing x to the power of a half, but we've also got a 3 that's on the outside. So that's, you multiply those powers together, so you get 3 over 2. So we'll have x to the power of 3 over 2. Now, I've got 5 times 8 on the top, so I've got 40, and 40 over x to the power of 3 over 2. We can also take this up here with a negative in our power. So y is equal to 40x to the power of minus 3 over 2. But either of those answers are good. Question 18. Work out the value of this fraction. Initially, it looks very complicated, given the fact that you don't have a calculator, because you just put this into a calculator, right? But you don't have a calculator. So what we're going to do is let's convert this into a top-heavy. So we've done that for both of them. Okay, so top-heavy. So 5 times 9 plus 4, 49. 5 times 9 is 45 plus 4 is 49. And 4 times 3, 12 plus 2, 14. So 14 over 3 and 49 over 9. And then we just wrote the powers, or this one just had the power. Now, going across, what does a negative mean in the power? It means you flip these. Okay, just change them around. So 9 over 49, and now you got a positive power. Okay, that's my next step. I also did the same thing with the negative power on the 2 to the power of minus 3. Okay, so I did 1 over 2 cubed. And then 1 over 2 cubed is 1 over 8. So I've also done that as well. Now, let's deal with this. How do I deal with that? The half is affecting the 9 and the 49. Half means square root. So I did the square root of 9 over the square root of 49. So square root of 9 is 3, square root of 49 is 7, which I wrote 3 and 7 right there. So I've got 3 over 7 times by 14 over 3. Now I've done lots of crossing out, and I'll just explain what I did. So I had initially 3 over 7 times by 14 over 3. 3 and the 3 here, they cancelled, and the 14 and the 7 we can divide by 2. So I had 1 over 1 times by 2 over 1. So 1 times 1 is 2, 1 times 1 is 1. So a total of just 2. So I have 2 over 1 over 8. I haven't touched that yet, so I've just continued that along. Now, I have 2 over 1 over 8. I'm going to make the division into a multiply, and I'm going to flip the 1 over 8 around. So I have 2 times by 8 over 1. 2 times by 8 is 16. My answer is 16. Question 19. Solve this algebraic fraction, giving your answer in this form. So what I want to do here is I'm just going to deal with this side right here, the left-hand side. All right. So I'm going to make this into one fraction by multiplying, cross multiplying. Okay, top and bottom. So these two will multiply as a denominator right there, common denominator, and the x minus 1 I'll multiply up there, and the 2x minus 1 I'll multiply with the 3. So the x minus 1 I did multiply. I didn't need to show all of that, but that's where 1 times x minus 1. And here 3 times 2x minus 1. And I'm going to now simplify this. Okay, and equals 1, I just carry it along. So on the top, I get 1 times that, which is basically x minus 1. Multiply this bracket out, I get 6x minus 3. I also took this bottom denominator right there, okay, and I multiplied it up here with the 1. So there you go. Okay, the 1 doesn't need to be written as I did here. And then I expanded the brackets out. I got 2x squared minus 3x plus 1. I collected the like terms here, and I got 7x minus 4. So I've got this equation simplified so far from here, up there. All right. Now I've taken everything over to one side, so I want the x squared to be positive, so I'm going to take 7x and the minus 4 to this side right there, giving me 2x squared minus 10x plus 5 equals 0. Now, because I know the question wants me to have it in this form, I know that I can't factorize this using those nice brackets. So I use the quadratic formula. So a is equal to 2, b is equal to minus 10, and c is equal to 5. Plug them into my quadratic formula. Okay, again, I've got a lesson on that if you need to go over that. Okay, plug them in, simplified step by step as I've done here. Okay, you can see what I've done with the steps. And then I've got this answer right there. So 10 plus and minus root 60 over 4. Now, root 60 over 4, I broke it up. Okay, it's a third. I can do 4 times by 15, or the root 4 times by root 15, which gives me root 60. Root 4 is 2, so 2 root 15 is my simplified version for root 60. So that can now be replaced right there, and now I've got 10 plus and minus 2 root 15 instead of root 60 over 4. Now 10, 2 and 4, common factor, 2 can be divided by 2. So 10 divided by 2 is 5, 2 divided by 2, 1. We don't need to write that here. 4 divided by 2 is 2. So my final answer is 5 plus and minus root 15 over 2. If we go back to the question, our p-value is 5 and our q-value is 15. So p is equal to 5 and q is equal to 15. Done. Question 20. The center of a circle is the point with coordinates minus 1, 3. The point A with coordinates 6, 8 lies on the circle. Find an equation of the tangent and give your answer in that form. So what I've done here is a quick diagram of what's going on. We have a circle, the center is -1, 3, and we have a point on the circle, and the point is 6 and 8, and we are told that there's a tangent right there, and tangents are going to be in the form y equals mx plus c, and we need to find the equation of that tangent. Now, what do we know here? We know that the gradient of the radius is going to be the negative reciprocal for the gradient of the tangent. Okay, so if one of them is, let's say, m1, therefore m2 is going to be -1 over m1. Okay, so let's do that. So how do we find a gradient here? We've got 2 points, and we can just use our y2 minus y1 divided by x2 minus x1, which I've done here. So 8 minus the 3 divided by 6 minus -1, which is going to be positive. So you get 8 minus 3, which is 5. 6 plus 1 is 7. So 5 over 7 is the gradient of this. So therefore, the negative reciprocal, right? I'll just do that up here. So the m2 is going to be -1 over 5 over 7. And the 7 goes up here, multiplies, so it becomes 7 over 5. And of course, the minus is right there. But what you can think of is flipping it and putting a negative sign. I've got also a lesson on this on the channel, so do go and check that out. So we know that the gradient is this for the tangent. So we can write it in the form y is equal to mx plus c. So m we know is -7 over 5. X plus c, we just need to find the value of c. How? By substituting a point right there, because it goes through the tangent. So we can sub 6 and 8 in here. So 8 will be our y right there, and x will be our 6. So plug that in, work that out, and then you know the rest. C is equal to 82 over 5. Now I have y is equal to -7 over 5x plus 82 over 5. However, if you look at the question, it says it wants it in that form where a, b, and c are integers, whole numbers. So if you go back down here, you will see that we have a fraction right there, and they have a denominator of 5. So we can multiply the whole thing by 5. So the 5 will go up here, giving you 5y, disappear from there and disappear from here, leaving us with -7x plus 82. Now we want to make the x positive, and we want to make the 82 go over to the other side as well. So 7x plus 5y minus 82 equals 0. And now we have the grand finale, the question that gave many of you nightmares. Right, now, before I go into this question, I'm going to need to show you what's going on, because there are several ways that you could actually work this out, depending on how you look at it. All right, so I am going to show you right here how I am going to solve this problem. All right, now what I'm interested in is that middle circle right there, and I want to find the shaded area. That's what the question says to do, giving you answer in terms of pi. All right, so let me explain to you what's going on. That's that middle circle right there. Okay, and I want to find that shaded area right there. Hopefully the drawing's nice. Probably isn't, but bear with me. I want to find that. Right, how do I find that? Well, imagine I find the area of a full circle, and I take away this part and I take away that part. That's it, right? That's all I want to do. The area of the full circle, take away this part, take away that part. Well, this part and that part are belonging to these other two circles. And all we need to do is just, they are symmetrical, okay? They're the same circle, all right? Each of them have the same radius, so they are identical. I shouldn't say symmetrical, identical, all right? So I'm just gonna find one of these parts, okay? This whole area, this, let's call it this oval thing here, right? And I'm going to times it by 2, and we're going to take it away from the full circle. Okay, let's explain. So first of all, let's go and find the area of circle B, the full circle. Pi r squared, right? So r, the radius is 4, which we told in the question. Okay, right there. So from the center to the circumference is 4, and it's 4 the other way as well. But I'm just going to use 1 as an example. So I'm going to do pi times by 4 squared, which is 16 pi. I'm going to bank that. Okay, that's the area of my full circle, 16 pi. Now, all right, and I need you to bear with me on this. Remember, I just need to find the area of one of those whole things, but I can't do it all in one go. I'm going to look at it step by step. Let's look at a segment. We want to find that shaded bit, which refers to this, okay? So how do I find that area right there? Well, we know theta over 360 times by pi r squared is the formula, right? For the area of the full segment. So we're going to do the area of the full segment, and we're going to take the triangle part away. And that will leave us with the shaded part. That's what I've done right here. The theta is the angle over 360 times by pi times by 4 squared, which gives me all of that area right there. Okay? And then I'm going to take away the triangle part. And the triangle is a non-right angle triangle, so I have to use the half AB sine C formula. Okay? So half times by radius, which is 4 times 4. I don't know if you can see that very well here. So I do apologize if you can't. So it's half times by, let me write it here. In fact, let me write it out again. I can't have you looking at that when it's like that. So half times by 4 times by 4 times by sine 60. Okay, that's what I want to work out. This is the area of our triangle. Remember, just to get, just in case you're a little bit confused, we want to find the shaded part right there. Okay, we want to find the area of the full segment, which is all of that, and take away the area of the triangle, and then that will leave us with this, as you can see what I've done here. So going back to the triangle, half times by 4 times by 4. 4 times 4 is 16, times by half is 8. So we've got 8 sine 60. Now, what is sine 60? You should know these triangles, okay? If you don't, then, you know, do go back and look for those triangles. But when you have a sine 60, sine 30, or cos 60, cos 30, anything like that, or cos 45 as well, then you can use these triangles. So sine 60 is root 3 over 2. Remember, no calculator, so you have to be able to work this out, okay? It's something that you need to know. So sine 60 is root 3 over 2. So I'm going to do 8 times by root 3 over 2. That gives me 8 root 3 over 2, and the 8 and the 2 will be divided. So I can divide by 2. So I get 4 root 3 instead. Okay, so this part, going back here, this is from here. So I have 16, 4 squared is 16, and 60 over 360 gives me 1 over 6. So I have 16 pi times by 1 over 6, which I can write as 16 over 6, which simplifies to 8 over 3 pi. So 8 over 3 pi minus 4 root 3 is the area of one of these segments, okay, the shaded part here. And we have 1, 2, 3, 4 of these in one of these ovals, which I'm looking at. But we'll come back to that later, well, at least we know what one of them is. Now let's move on. What I did next was, if you see this shape here, it's not drawn very nicely, but this is simply one of these sectors, okay? One of these sectors right there. Sorry, let's do that again, right? So let me trace through this with a different color pen. So this right here, what I did is this right there, going here, going along like that, and that. And this angle right here is 60 and 60. So that, oh, I didn't explain all of that. So because the radius is 4 centimeters, we have 4 centimeters there. From there to there is 4 centimeters. From this center of the circle B to the edge is also 4 centimeters. From this center B to this edge right here is also 4 centimeters. We end up with these equilateral triangles. And equilateral triangles have all 3 sides the same, and the angles are 60 degrees. So now we know that each of these angles are 60 degrees. Now, if we're looking at this right there, which I've just traced through, this is that which I've drawn here. These angles, this angle rather, is going to be 60 plus 60, so it's going to be 120. That length right there is going to be 4 centimeters. That length right there is going to be 4 centimeters. If I want to find the area, and this is exactly what I've drawn right there, okay? So if I want to find the area of this sector, right, what do? I do theta over 360 times by pi r squared. That will give me all of that. So what I'll be doing is I'll find the area of all of that, including this part of the sector, or the segment rather, okay? All right, so because that will include that, okay? That would include all of that right there. Okay, it would include all of that. So I'm finding the area of all of that. Right, hopefully you're understanding this. Just go back over it if you need to, if you missed an explanation or something, because it's really, really critical that you understand every step as we go along. Otherwise, if you just miss a step because you weren't paying attention, then you won't understand what I'm doing and the next part and the next part, okay? Right, so area of sector, 120 over 360 times by pi times by 4 squared. This all simplifies to give me 1 over 3 times by 16 pi, which gives me 16 over 3 pi centimeters squared. So what is this? 16 over 3 pi is the area of all of that. That leaves me, so I know the area. Remember, I'm finding the area of one of these ovals. All right, let me just draw that like that. Okay, I'm finding the area of one of these ovals. All right, I've just found that. I've just found the area of all of that right now. Okay, that's that. That's what this is. I just need to add this part and that part, which is that and that. How many of those? 2 of those. So here we go, my very badly drawn diagram probably. So the area of one of these ovals is going to be the area of the sector, which is 16 over 3 pi, right there, plus 2 lots of those. One there, one there. So 2 lots of 8 over 3 pi minus 4 root 3, right there. Expand this out, okay? So this is just that. And if you expand this out, you get 16 over 3. Expand that out, you get 8 root 3. Collect the like terms right there. That's 32 over 3. And then that's on its own. So I've got this is the area of one of these full parts. How many of those do I want to take away? I want to take 2 away from the full circle. So here we go, the final step. So what I've done here is I've multiplied it by 2 because I've got 2 of those areas. So this answer here, which is the oval, the area of the oval, times by 2 gives me that. So times that by 2 is 64, times that by 2 is 16. And then the shaded region is going to be going back to the area of my circle. I'm going to do 16 pi minus 2 of these ovals right there, the answer to that. And then I expand this out. Well, I don't really, I just take it out the brackets. I got 16 pi minus 64 over 3 pi plus 16 root 3. I'll do 16. Remember, these are the pi's are the like terms, so I can collect. So it's a little bit rubbed out here. I need to do 16 minus 64 over 3 without a calculator. So I've done that right there. So 16 over 1, I've made that into a fraction. I've ignored the pi's because I don't really need them for this part of the calculation. I've made the denominators the same, so 48 over 3, so multiplying that both top and bottom by 3. And then I've got 48 minus 64, which is minus 16 over 3, which is right there. So when you add these two up, you get minus 16 over 3 pi, and then plus 16 root 3 as your final answer. So I've just changed the order around because I don't like starting with a negative, and I've got 16 root 3 minus 16 over 3 pi. And that is your final answer. Hope you enjoyed this lesson. Please give this video a thumbs up. Do spread news about the channel to your friends and your family, anyone maybe who's currently in year 9 or 10 and they're going to be taking the GCSEs over the next few years. There'll be lots and lots of GCSE and A-level content for them to revise from and to seek help. Until the next one, guys, goodbye.